Okay, math 3, we're on 1.2, and look at all this stuff we're doing. Whoa. Okay, so we're still working with rational functions. That's where we have a polynomial divided by another polynomial. So expression divided by expression. And we're finding the x-intercepts and asymptotes, just like we've done before. We're adding in domain and range, and we're still doing wholes and graphing. So look at all this vocabulary. Dang. Rational function, x-intercepts y equals 0, y-intercept x equals 0. The vertical asymptote comes from the denominator. And the horizontal asymptote, I put this little graphic in here. There's 3 different options depending on the degree of the top and the bottom. Domain is x values, range is y values, and then we still have our wholes where there's common factors. So we're going to go through all of that. Okay, here's our rational function. We're going to determine the asymptotes. Are there wholes, intercepts, and we're going to graph it. I should have probably added domain and range on that. But in order to find wholes, and the easiest way to see vertical asymptotes, we want to factor. Okay, so I'm going to take the numerator and factor that, and then the denominator and factor that. Is it -2? Yeah. So these are easy to factor because a equals 1. It's 1x squared. So that means we're only looking at the last one, 1 times 6 or 2 times 3. Both of those add or subtract to 5. So that one's a little tricky, but it's a positive 5 and a positive 6. So think about if you have -1 plus 6, that's going to multiply to a -6, and it has to be positive. So we're going to use 2 and 3 as our factors. So 2 plus 3 is that 5. 2 times 3 is 6. So over here, our only options are 1 and 2. We just got to figure out how to put them. So -1 plus 2 gives us this positive 1, and they multiply to the negative. So x minus 1, x plus 2. Okay, so I'm just going to rewrite. We have x plus 2, x plus 3 divided by x minus 1, x plus 2. So first thing I want you to notice is these are the same. That gives us a whole when we cancel them out. So to get the whole, we solve that factor that we just crossed out. So x plus 2 equals 0. I'm going to -2. So there's a whole at -2. Okay, to find the vertical asymptote, we take the remaining factor on the denominator and solve that. So x minus 1 equals 0. If I solve that, I get x equals positive 1. And that's our vertical asymptote. I'm going to put VA because I'm kind of running out of room. So x equals 1. I can put that on the graph right now. That is my vertical. For horizontal, we want to look at the degree of the top and the bottom. So how many x's are on the numerator? Well, there's 3, but we want to look at the leading number. What's the highest degree? 2. And on the bottom, what's the highest degree? Because there's 3 x's, but 2x squared is the highest degree. That's the exponent. When I'm talking about degrees, I'm talking about exponents. Okay, so these are the same. And I'm going to come down here. When the top and the bottom are equal degrees, we take the coefficients in front. So for this example, it's 2 over 1. For ours, over here, it's 1x squared divided by 1x squared. So 1 over 1 equals 1. So that's our asymptote. Y equals 1. That's the coefficients from the leading degree. So right here, y equals 1. That's our horizontal asymptote. So now we need to get some intercepts. So we do that by putting in 0 for x and y, or you can just graph it in a calculator. I'm just going to graph it and see if I can get them, just because I'm running out of room to type. Or not to type, to write. So I have x squared plus 5x plus 6 divided by x squared plus x minus 2. That doesn't look right. There we go. So here's our intercept. So negative 3, 0 is the x. And then 0, negative 3 is the y. So negative 3 and negative 3. But remember, there's a hole at negative 2. So when I hit negative 2, it's undefined. So how we draw that on a graph is I'm going to come here and graph it. Then once I hit negative 2, I draw a circle. There's my hole. And then it goes down. So if I were to write the domain of this piece of line, it would be negative infinity. And then there would be a break at that hole at negative 2. Then I would pick up at negative 2, not included. It's like I'm looking at the left of the hole and the right of the hole. And then we go to the asymptote, which is x equals 1. And then over here, we pick up at 1 and go to infinity. So I would union again and then go 1 to infinity. So my domain includes the hole and the asymptote. Okay, so range is the y values. Let's just do it because we're doing domain. Range, you go bottom to top of the graph. So the bottom, we're down here at negative infinity. And then again, there's a break at this hole. The problem is we don't know what the y value is. These are a little harder. You usually don't do range when there's a hole because you have to look at each side. So like, I'm going to make a table. If I do x values at 2.1, that's to the right of the hole. Sorry, negative. I'm like at 0.3. Okay, and then the other way would be leading up to the hole. That would be at like negative 1.99. So it's about negative 0.3. Sorry, I didn't plan on doing the range, but we're doing it. So right here, there's a break. We're going to say it's at negative 0.3. And then same thing. We pick up and go to the asymptote. And then we pick up and go all the way up to infinity. So range works the same way as domain, except you're going bottom to top and it's y values only.